Okay. All right. So my topic for today is let's fight Redux side effects showdown. So let me start by asking you a question. How many of you have used a side effect library before? Okay, that's a good number. And how many have used Redux before? That's great. This is perfect. So my name is Ankita Kulkarni, and I'm a software developer at Wrangle.io. Today, I'm going to battle three popular side effect management libraries, thunks, sagas, and observables. So when you start a new project, it's always important to start it right? So it's really important to pick, the asynchronous tasks and how to manage them really well. Just because handling asynchronous requests are really complex, right? So let's begin. So why Redux? Redux is the preferred state management library. In Redux, you have like actions and reducers. When you declare an action and basically fire it off, it was going to go to the reducer, and reducer is going to make those changes. Redux helps manage state in your JavaScript apps. It's really important when you start building JavaScript and you're thinking of scalability to have something like Redux in there. It puts all your data in a store. And you will hear store a lot. So basically think of store as like, storing all your data, but as you refresh the page, it's going to go away because you have to sort of manage that in a better way. So this is the base of Redux. As I already mentioned, there's going to be an action. Actions are sort of like commands. Hey, just do this, or I should say request to do something. And there's a dispatcher in the middle, there's a store, and there's a view layer attached to it. Every time you send an action, things will happen in the reducer, the dispatcher will take over, and it will update your store. At the same time, the view layer is also listening to that. Now, in this case, like, view layer could be anything, right? It could be using Angular, it could be using React, or any other popular frameworks out there. But one thing to note, our actions are basically plain objects, right? And reducer listens to those commands and acts on them. So what are side effects? Who here knows what are side effects? Okay, that's a good number. So basically, side effects are any sort of like managing your asynchronous task. Anytime you're performing like anything async, that sort of becomes your side effect. And it's really important to think about that from the beginning of the application, just because your application state is pretty unpredictable, right? If it's as simple as you send a request and things happen, life is not that simple, unfortunately. And developers have to make sure that they are actually being managed pretty correctly. And each middleware library performs its own side effect management in a very different way. So as I mentioned, we are going to look at 3 different ones. But first, let's take a look at how popular those are. Okay, so I pulled up these numbers from GitHub, as you can tell. Redux thunks, about 11K. Saga, 16, and observable, 6K. So does that mean, based on the popularity, we should go on the basis of GitHub scars? Not really, because we'll see why, and we'll reason about them as well. But yeah, these numbers are obviously approximated, so it's not the actual numbers. I'm sure when I built the slides, I just approximated them. So as I mentioned in my talk description as well, we'll start with login and build our application further. Now, why login? Because which app doesn't require login? A lot of apps do. And that's why login is simple to really understand. At first, when you start building your application, login is pretty simple, right? You send a request with your credentials, and if they are valid, you sign in. But if not, you don't, right? So when you send a login request, either there's a success or there's a failure. So you can sort of think that there is an action type for login request, there's going to be an action type for login success, and an action type for login failure. And this is pretty simple. Let's see how we can declare those actions. You're going to see code along the way. And that's, some of it like most of it actually works, so you can just basically grab my slides and run it in your application. But it's just to basically get an understanding on how login initially works, and then we can build the application further. So yeah, this is how a login request looks like, and how you would like declare an action. Same thing with login success. In login request, as I mentioned, the payload would be username and password. With success, login success, and we might need some sort of user profile after the user logs in, so we know that they have logged in. And login failure. So in case of any error that happens, just throw it in the store, and error is true. And then we have reducer, which are actually going to listen to those actions. So like in this case, in case of a login success, we take in the user object and we added it to the store in the store. Same thing with failure. Otherwise, always return the same state if something were to go wrong as a default way of doing things. But it's not just this simple, right? Like our application will grow further. And things get really interesting with async, because managing side effects is really hard. It adds a lot of complexity in your code base. It's important to do it right. Your actions and reducers, as you think about it, are not necessarily going to change. It's the middle layer, which is the middleware, which is going to. And that's why it's really important. And as we tour all the middlewares, you'll sort of see the pros and cons of each. But doing async requests is really important. So let the battle begin. Before I dive more into code, I'm going to show you I'm going to talk about a little bit about the mental model of each of these. So Redux Thunks uses promises as their base model. And we'll look at an example, so things will get more clear. Redux Sagas have like a worker watcher model. So as the action type, let's say a login request is being sent out, and if it matches, a worker is going to just work on that request. And observables have this concept called epics. And every time an action type matches, we are going to use observable RxJS operators to do that. Observable uses RxJS, which is like reactive programming, and everything is a stream. I'm not going to dive a lot into RxJS because that's going to be another topic. So I'm going to give you an overview of what it is. And we need an example, because we spoke a lot of theory now. In this case, like login thunk. This is like a thunk example. It takes in a username and password, and it has this dispatch function as part of it. Every time you dispatch, it returns a promise. So I'm dispatching a login request, and then login user API call is essentially an API call, right? Which is sort of like a mocked version here. And if that resolves, then we will basically dispatch a login success action. And in case of error, we can dispatch a login failure. But you can sort of start to see now, it's going to be really hard to test whenever we get into thunks, because dispatch is a part of it. But at the same time, you get dispatch. So for smaller apps, it's going to be really easy to actually use thunks. And that's why even when I got started with using Redux middlewares, I started with thunks. And I got started right away because it was that easy. Sagas. So Sagas uses something called JavaScript generators. And if you have used, and I'm most likely sure that if you have heard of generators, it's because of Sagas, because I learned it that way. Generators are sort of like a channel-like abstraction, essentially. And each Saga it acts like a generator, which will generate a set of side effects. In this case, as you can see from the package Redux Sagas effects, I'm using call, put, and take. And we'll see a little bit further what those are. So this is essentially a worker watcher model, right? So this is the login user worker, and this is the login user watcher. As you can see over here, I can see if I can point. Interesting, it doesn't work. Anyway, so as you can see over here, in the login user watcher, take is going to listen to any login request action. So the first time it gets are fired, it's going to listen, the watcher is going to listen and say, hey, worker, go do your job. And whatever code is there in the worker, it will run that. Again, it looks pretty similar because we are going to repeat the same thing over and over, but it's just a way of doing this in sagas. As we get the payload, we basically yield a call, which is basically making that API request for us. And in the user object, once we get that, it basically makes it more synchronous. So once we do get the user object, it's going to dispatch login success. But if for some reason, that doesn't work, it's going to dispatch login failure. And so the middleware's job, so instead of running fetch in your components, in whatever your front-end code is, it's going to listen to every action to the store and perform that using generators and Saga effects over here. Let's look at observables. Same idea with observables. It uses RxJS, and it has, just like Sagas have effects, it has operators. And you will have a lot of different operators in RxJS. And honestly, even though I have used observables in several projects, I'm still learning, because every time I forget what's the difference between, switch map, merge map, flat map, all sort of maps, right? But as you build more and more applications, and as you refer the documentation more, it's going to get more clear. And let's look at what's happening line by line, right? A login request epic, same idea, right? It takes in an action. It's going to pipe. In Sagas, we have to specifically say, hey, send a login request action for that to happen. Observer is going to filter through a lot of different actions. So every time we fire off an action, it's going to check if it's of the type login request. And if that's the case, it's going to merge map it and basically invoke that API call, right? And if that works, the off operator, it's going to, or off from RxJS, is basically going to dispatch an action, login success, or in case of an error, a login failure. And I personally find that, which operators to use as you get more and more familiar, observers get really, really powerful. But this is how the gist of it, right? As you build more applications, you will get used to it. RxJS is a really, it uses a concept of streams. Every time you make a change, you dispatch an action, you basically think of it as an array of things. And every time you're making a change, it's actually going to affect that array, and it's going to affect the same stream, essentially. But only if life was this simple, right? Like real life is pretty hard. We are not just going to do request, success, and failure, right? Because there's a lot that goes on apart from login. So in a real world, this is how our application ends up looking like. When you do send a login request, there's an async of some sort. On login success, gets fired on success or failure. But in addition to that, there's logging analytics, loading the data for dashboard, checking access control, user profile, and more stuff. I can't even describe, depending on your application. It's going to get really complex. And as we all know, users are very notorious, right? We all are one of them, because we like to click the same button over and over again. So a quick fix to that is disable that button. But I'm a developer, I know DevTools. I'm going to go into DevTools and re-enable that button, because I'm pretty notorious, right? But we need a better way in side effect management to handle that, so that we don't have to deal with all that. Now you can be like, but I'm just going to disable the button. I'm not going to worry about that of any sort of cancellation and whatnot. And that's totally cool if that's what your application requires and you are in a mobile app or something, right? Or if you're using specifically React Native or any sort of Vue Native or whatever. So hence, it's really important to take care of things like canceling, debouncing, and all of that, because your application is going to get complex. So let's look at a bit more complex example, now that we're a little bit more familiar with login, right? Who is a Netflix user over here? I should see like all hands up right now because I love Netflix. So if you have seen Netflix, how often have you changed your mind when you thought of watching House of Cards and switched to, let's say, Sabrina or like Quantico or anything else? This is my Netflix, by the way. I really like all these shows and movies. Uh, so when I want to watch House of Cards, I've changed my mind and I just want, the new season of Narcos is out. I literally want to check that. But and I know I'm going to change my mind a lot. I might even end up closing Netflix because binging is bad for you. I should be doing real work, right? But what the users don't know that we developers do, that we have to handle cancellation there. As you can see, when I did go to House of Cards, and I changed my mind and I started watching Sabrina because I heard that show is really good, I literally had to handle cancel the request. So what's going to happen when that request does come back from House of Cards is going to override, right? And an application like Netflix is really important to handle all those scenarios. So let's take a look at a very dumbed down version of Netflix that I created, and on how canceling requests should work, right? So first, I know you're thinking Game of Thrones is not on Netflix. We have already checked that, right? And that's why this is my demo, and I added Game of Thrones here. Because why not? I'm fetching Game of Thrones. It's loading. I'm fetching Office. I decided I want to cancel it, right? And then I decide, okay, you know what? I'm going to fetch Office again. And I'm going to keep doing this over and over because I change my mind a lot. But your middleware should take care of that. Users should not worry about, oh my God, what their code looks like. I do think as a developer because I'm a developer. I have that habit. How are they doing handling these requests? But that's a different story. So let's see how to do it in all these three different middlewares, right? In Thunks. Don't try to do it in Thunks. It's really hard. Oh my God. Like, even when I was putting together a demo for this, it is hard to cancel requests because if you think about it, it's a promise, right? You can't, like, it's going to either result into a resolved promise or it's going to result into a rejected promise. There's no cancellation, debouncing, and whatnot, right? So the conclusion is it's very hard to cancel requests in Thunks. I mean, I'm sure you can do it. You can figure out a way. You can add like some sort of generators and whatnot, and then it will end up looking like a saga. But it's fine. Like I'm sure like there's some way of doing it. But it's really hard to do it, and it's not worth your time to figure out something that the middleware should automatically provide, right? Let's look at sagas. Again, just because we are talking about movies, we all love movies. I've changed the example a bit here. Same idea, right? On a movie request, it's firing off a movie worker, right? In that case, it's literally doing the same thing. There's a load movie API call. There's a success and a failure. We have already seen that code. We're already a little bit more familiar with it, right? So let's look at the watcher and how sagas would handle it. It's going to listen to a request, and we are going to fork it. Again, that's another way of like basically getting a copy of it, essentially. And it's going to listen on any canceled action. And until that happens, it's going to keep going on and handling all your requests. But if that doesn't happen, it's going to cancel it, right? Because if a canceled action is fired. In observables, this is how it looks like. Same idea with the code, but I've added a delay. I added a delay a bit because it was really hard to build that demo where I wanted to show a loading because I was returning a promise. So it's really, in the production code as well, like you might see a delay there. But what's important here is take until, right? Observables, it's really easy to handle cancellation requests. Wherein, again, you're piping, you're checking if the action type actually matches to watch movie canceled. And if so, then cancel whatever you're doing. The result is not going to come back. So I won't get to watch House of Cards because I've changed my mind, right? And the repeat at the bottom, it's essentially going to repeat this action because I keep changing my mind over and over. Without a repeat there, it's only going to handle it once. But again, async stuff is harder, right? This is just the beginning of it. We talked about canceling requests. We are doing many things at the same time. So what we want to do is again, on login success, we want to look at log analytics, loading movies for dashboard, checking if the users have necessary access controls because, we have different profiles. We have shared access and everything. We want to show our profile and again, do more stuff. But for now, in the upcoming example on how we actually handle several requests and how the middleware could do it, let's look at that further. So for now, we are going to focus on analytics and loading the movies for dashboard whenever a login success event is fired. Again, thanks. I'm sure you don't have to nest it so much, but this is the gist of it to get a point through, right? A thunk on, I'm just called a Netflix thunk. I'm sure we can come up with a better name. On login request, login API call, all that code we have already seen so far. And on watch movie API call, I'm going to dispatch a success in case of a movie. And at the same time, I want to log analytics and whatnot, right? And I'm doing several things at the same time. It's really hard to read this code because even when I'm trying to explain it, I'm trying to take an extra mile. I'm going an extra mile to do it just because I'm it's really hard. I don't know what's going on. So the point being that if this application was simple, right, our thunk wouldn't look like that. Our thunk would look way simpler. So let's, and does this remind you of something like callback hell? So it's really hard to test. It's really hard to reuse. And this is I don't even want to start debugging if something were to go wrong. Obviously, I could use DevTools, but, to be honest, I'll put console logs everywhere. And that's just going to grow my thunk even further. Sagas. Sagas, I'm not showing you the same code over and over. So watch movie worker is going to be sort of the same idea. Same thing for log analytics. But the way you handle this in Saga, several requests, is essentially, you basically wait for an action. And as the watcher is waiting for an action, you load the watch movie worker, and you dispatch a watch movie success action or a log analytics action, right? And this code is way more readable, and you can do way more things with this code versus the other code. I could also reuse this code in other different places if I wanted to. Now, observables. In observables, again, when a login success action happens, so observables, the log analytics epic is going to check if the action is of type login success. If so, perform whatever you wanted to perform, and then merge all the events and dispatch a log analytics action, right? You can sort of see canceling requests, doing multiple things at the same time, sort of become a lot easier. And it feels like, oh, I can manage this, right? Same thing with watch movies epic. It's going to look like something similar. Again, it's much more functional. I really like functional programming. It's much more functional. I mean, it's not a pure function, obviously, but it's I can read this code. I can reuse this wherever I want. All I need to do is dispatch an action for doing that. Epics are going to be, the store is always listening for all these things. And hence, it just becomes way easier to manage as well. So what is the summary from all this, right? We went through a bunch of different examples. We talked about sagas, observables, thunks, right? So according to me, thunks are great for smaller projects. I would 100% tell you, go for, if you're new to middlewares, go for thunks. That's the first thing you should be learning. Once you get the idea of it, then move on to other bigger middlewares. So the pros and cons. I know it's a big list. I'm not going to go through it all, but this is sort of like a cheat slide, right? They're really easy to understand and can be used for smaller projects. But there are a lot of cons here, right? Such as too much nesting, code readability, and hard to test. I really care a lot about testing, and it gets really hard to test with thunks. Sagas, on the other hand, the pros are you got to dispatch a separate action. So in observables, it's going to filter through a list of actions. So you can imagine as the application scales, it's going to, you'll have a lot, like hundreds and thousands of actions, if not. And then it's going to filter them out. But in Saga, you need a separate action. The pros, I mean, ES6 generator knowledge, if you already know async await, you're sort of like familiar with the code. They're easier to test, has cancellation, racing conditions and everything. We saw some of the complex examples here are built in. But again, ESX generator knowledge can be hard for some if you're not that used to it, right? And also can be harder to maintain if not done right. Because it's really easy to just, basically copy the same code and paste it again versus actually make it more reusable. And in observables, again, the pros are you need to know RxJS knowledge. Same thing, RxJS has a huge learning curve. I've worked on it on a few projects. I'm still getting used to it, although they are very powerful, right? But not all that apps require that much power. Two, observables are lazy. You can retry, repeat, and testing is also very, very easy, right? Actions in, actions out, and mock the functions, which is very, very easy and can be reused very easily. So, any guesses who won in this battle as we went through the pros and cons of each? Oh my God. Okay, that's good. I like how you think. According to me, based on the several projects that I've worked on, it is Sagas. Boo. Well, the reason being that not all applications require how powerful observables are. Not all applications are going to require that much power, right? If you're, let's say, building a POC, I wouldn't even look at sagas or observables at all. I would just go for thungs. As to a extent that an application starts growing, or if you can sort of see that the application is going to grow, then I would move on to much more powerful middlewares, right? They're easier to learn, easier to test. We all know how to split up functions into smaller functions. And as you build more and more, it's like you start of noticing that all you got to do is just dispatch that extra action, right? I want the same data here, dispatch this action. But there's a but to this, right? Each middleware has their own strengths and have their own weaknesses. As I said, it's fine. Thungs are small for small projects. Someone who's new to it, it's all good. Redux sagas are great for handling multiple simultaneous things and for complex orchestration. And observables, as I said, sometimes your application is not that complex. We all want to build Netflix, but we are not always building Netflix, right? And that's why I personally, if I were to determine the complexity of the application and be like, okay, I know you want to go long term and sort of pick the best tool for your project because you can sort of see it scale, but really talk it out with, what's the scope of your application and see if you really need that much power, right? And that's why, like, I personally feel like sagas are great if you want to, basically have a balance of learning versus power, right? And having said that, thank you so much. And that's my talk on Redux side effects middleware.